All right, welcome back. Starting off third quarter, we are going to do a little bit of review, and then we are going to jump into some factoring that will be new and will be quite a bit more challenging than what you did in intermediate algebra. So the first thing we're going to start off with is factoring by GCF, just reviewing what factoring by GCF is. So GCF stands for greatest common factor. So what we're going to be doing is we're just going to be looking for the greatest common factor between different numbers, different variables, and factoring that out. So there's two different things we have to worry about, and there's basically two different rules that apply to, or one rule that applies to each of those things. So there's two different rules. So the first thing we have to worry about are the numbers that are involved. So anytime we have numbers involved, and we want to find the GCF, what I would suggest you do is just look at the smallest number. Okay, so in this case, the smallest number here is 28. And I would look at 28 and I would just list all of the factors of 28. So I know that 1 times 28 is a way to make 28. So I can say 1 and 28 are factors. And then I know that 2 times 14, so I can say 2 and 14 are factors. And then I also know that 4 and 7 can multiply together to equal 28. So I know that 4 and 7 are factors. Now there's a bunch of different methods for how you can go about finding all the factors of a number. If you're unsure how to find the factors of a number, what I would do is just grab a calculator, and 1 is obviously always going to be a factor of each number, but then I would just go through the list: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, and go as far as you need to go, but then stop when you get to a number that repeats. All right. So in this case, I've got all the factors of 28, and what I basically just need to do now is figure out which one of these numbers is the largest number that goes into 40 evenly. And if you just go through the list, well, 1 goes into 40 evenly. 28 does not, so we can cross that off. 2 does. 14 does not, so we can cross that off. 4 does, and then 7 does not. Okay, so 1, 2, and 4 are the only factors that divide 40 evenly. So the largest of those is 4. So the GCF of 28 and 40 is 4. Okay, similarly, we can look at a group of 3 numbers, and I'm going to do the same thing. I'm just going to start with 15. And I'm only going to look at 15. And so the factors of 15 are 1 and 15, because 1 times 15 is equal to 15. And then 2 doesn't go into 15. 3 does, and I know it's 3 times 5, so I can write 3 and 5 in the list. And then you'll notice 3 and 5 are right next to each other, or one away from each other on a number line. So if I were to try 4, I know 4 doesn't go into 15. And then if I do 5, well, yeah, 5 does, but it goes in 3 times. So that's where that's what I was talking about, where you repeat. If you repeat numbers, then you can stop, because you know you've found all of the factors. Okay, so in this case, we have 1, 15, 3, and 5. And now we need to look at 18 and 66 and determine if these numbers go into 18 and 66 evenly. So 1 obviously does. 15 does not. 3 goes into 18, and 3 goes into 66, so we can highlight that one. And then 5 does not. So in order for 5 to work, it would have to end in a 0 or a 5, and neither one of those do. So we can cross off the 5. So in this case, the greatest common factor between 15, 18, and 66 is just the number 3. Okay, so the general rule that you want to follow is the GCF of numbers is the largest number that divides them evenly. Okay, so that's really important that it's divided evenly. We don't want any decimals or anything like that. Okay, so when you're looking at the numbers, you just want to look for the largest number that divides them evenly. All right. So now we're going to deal with variables too. And variables are, to me, a little bit simpler. Um, when you're trying to determine the GCF of variables, you just look at the smallest exponent. So in this case, the smallest exponent is x to the third. So I know that x to the third goes into itself, right? I know that x to the third goes into x to the seventh. And you might be thinking, well, 3 doesn't go into 7 evenly. It doesn't matter with variables because all we want to do is take out the same number of variables from each one. So one way to look at this would be just to take each one of these and say, all right, I have x to the third is x times x times x. X to the seventh is 7 of them. And x to the fifth is 5. And then you just say, well, what do they have in common, right? Well, they have in common this 1x. They have a second x, and they have a third x in common. And so we don't care if 2 of them have more in common. We just ignore those because they all have to have one in common for you to identify it as being part of the GCF. So in this case, the GCF is just x to the third. And so really the simplest way to look at this is just look for the smallest exponent. Okay, so if you look at this next example, we have y to the fourth, and y to the seventh. Well, the smallest exponent is the y. So our GCF is just y. All right, so the general rule, or the thing that you want to do, is the GCF of variable terms is the variable with the smallest exponent. Okay, so we have 2 different rules we're following. One of them for numbers involves finding the largest number, and then for the variables, we want the smallest exponent. So it's kind of an interesting relationship there that is maybe a little easier to remember because of that. Okay, so if we put this into practice, if we put both of these things into practice, and we want to find now the GCF of these 3 terms, we just do this same thing that we just did. So we look at the 3 numbers. All right, in this case, we have some negative numbers. Don't worry about the negative because that's not going to come into play for the greatest common factor because the greatest common factor is never going to be negative. It's always going to be a positive number. And so I'm just going to look at the number 18. And I'm going to say, all right, I know that we have 1 and 18. And you can make a little list like this too if you want. 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and 6 works. So this is what I was talking about where you repeat, right? So I'm just going to stop here and I'm just going to cross off these last 3. And I crossed off that last one, even though it's factors, because I already have it listed in 3 times 6. Okay, so the 6 factors of 18 are listed right there. And now all I have to do is look at 63 and 27 and say which one of these is the largest number that goes into 63 and 27 evenly. So what I'm going to do, instead of starting at the bottom like I did before, I'm going to start at the top and look at the number 18. Does 18 go into 63 or 27? Well, 27 is pretty obvious. No, it doesn't. So I can cross off the 18. Does 9 go into 63 and 27? Well, 9 times 7 is 63. 9 times 3 is 27. So 9 does. So now that I'm working down from the top, I can just stop because I don't really care if these other ones go into 63 and 27 evenly because I've found the largest one that goes into those numbers evenly. Okay, so we're going to leave that alone. And now we're just going to look at the variables and say, all right, y squared, y to the third, y to the fourth. Well, the smallest exponent is y squared. So that means my GCF of these 3 terms is 9y squared. So I just combined the 2 things that I highlighted to find the GCF. All right, let's look at another one. Now, this one introduces 2 variables, and that's perfectly fine. And sometimes when we're looking at these, we can look at these numbers and we can say, well, 6, 10, and 8, well, they're all even. They can all be divided by 2. And, well, really, if we look at 6, it's 1 times 6 and 2 times 3. And 6 and 3 don't go into 10 or 8, so it has to be 2. Okay, and then if we look at the variables, in this case, we have a to the third, a to the fifth, a to the sixth. So we have a to the third here. And then if we look at the b's, we have b squared, b, and b squared. So we have two b squareds and one b. Well, b is obviously smaller than b squared. So our greatest common factor is just 2a to the third b. All right. So now these next two examples are basically exactly the same as what we did, except what we're going to do is we're going to actually factor these, and we're going to end up with the greatest common factor on the outside of a set of parentheses, and then we're going to have whatever's left that we need to multiply by on the inside. So there's a little bit different method for how we're going to do this. So what I'm going to do is I'm going to look at each one of these things and do what I just did to be able to find the greatest common factor. So if I look at 9, 18, and 12, well, 9 is the smallest number. So 1 times 9, 3 times 3. Okay, so, and then I look at 18 and 12. Well, I know 9 doesn't go into 12, but it goes into 18. So the greatest common factor between the numbers is just a 3. And then if I look at a to the 5th, a squared, and a, the largest or the smallest exponent is the a. All right, so my greatest common factor is 3a. All right, so I'm going to write that here. And then what I want to do is I'm actually factoring here. So I'm going to then make a set of parentheses. And inside the parentheses, I'm going to put a plus sign and a minus sign because we have a plus sign here and a minus sign there. And then what I'm going to do is I'm going to look at the negative 9a to the 5th. And I'm going to divide that by 3a. Okay, so this is where we're bringing back what we did last unit now, because so we've got exponent rules, right? The quotient rule. So the quotient rule says we divide the coefficients. So negative 9 divided by 3 is negative 3. So I'm going to write that negative 3 in here. And then a to the 5th over a, well, that's a to the 5th minus 1, so it's a to the 4th, right? So this is a to the 4th. Okay, so I found the first term that's inside the parentheses just by dividing negative 9a to the 5th by 3a, and I got negative 3a to the 4th. Okay, so I'm going to do the same thing with 18a squared, so I divide that by 3a. Well, 18 divided by 3 is 6. And then a squared divided by a is just a. And then I'm going to do the same thing with the last term. Okay, so that's not a pretty a. So here, that's a little better, I guess. Maybe not. 12 divided by 3 is 4. And since I've already put my signs in there, I don't have to worry about the signs here. So 12 divided by 3 is 4. And then in this case, the a's just cancel each other out. So I'm left with just that 4. So if I've factored this polynomial using GCF, I end up with 3a times negative 3a to the 4th plus 6a minus 4. Okay, so that's how we can use GCF to factor polynomials. All right, so here's another one. And hopefully you're going to get to the point where you don't necessarily need to write a lot of this down. You can just say, hey, you know what? I notice a 4, 16, and an 8. I know that 4 goes into all three of those numbers, and it's the largest because 4 is one of the numbers. Okay, so I know that I'm going to have a 4 as part of my GCF. And then the smallest exponent is b squared, so I'm going to write a b squared, make my parentheses, and then I'm going to put a, now one thing you could do, and I didn't do this with the last one, but this one starts off with a negative, so you could put that negative in there right away, and then have a plus sign, and then have a minus sign. Okay, so I'm just basically putting those 3 signs in there. So the negative, the positive, the negative. Okay, and then I'm going to do the same thing that I just did where I divide each one of these. So 4b squared. Okay, 4 divided by 4 is 1. So I can write the 1. I don't have to write the 1. And then b to the 6th divided by b squared is b to the 4th. So you don't have to write the 1 in there. That's kind of not the best looking b. You don't have to write the 1 in there, but you can if you want to. It's up to you. And then the next one, we're going to divide that by 4b squared. And so 16 divided by 4 is 4. And then b to the 4th divided by b squared is b squared. Okay, and then same thing with the last one, 4b squared. And again, we have the variable has the same exponent, so the variable is just going to cancel. And so the b squared just cancels itself out. So 8 divided by 4 is 2, so we just have a minus 2 here. Okay, so we just factored that polynomial by GCF. Okay, so you can kind of see a connection with last unit because of this quotient rule. And then one thing that you might notice is when we do that division, when I actually divide and create those 3 fractions, it's kind of like dividing by a monomial from last unit, where we had a trinomial with a monomial underneath it, and we split it into 3 fractions, and then we simplified each fraction. Okay, so that's the same thing that we're doing now to factor by GCF. So these things are all connected, whether or not you realized it or not. All right, so this one just maybe takes it to a little higher level. It's got some bigger numbers. It's got 2 variables in there. And this one, we can look at these numbers, and this is kind of nice because 15, 20, and 5, since 15 doesn't go into 20, but all of them are divisible by 5, we know that 5 is part of our greatest common factor. And then the smallest exponent, so the p squared is going to be the smallest on the p, and then the q to the 3rd is the smallest on the q. So I'm going to write 5p squared q to the 3rd. And then again, create your parentheses, and you're going to always have the same number of terms inside the parentheses that you do in your original polynomial. And now some people, nope, it's not going to do it with this one, but sometimes when the greatest common factor causes one of the terms to become 1, some people think it just disappears, but it doesn't. And hopefully, I don't know if I have an example like that. If we don't, maybe I can make one up. All right, so I'm going to divide each one of these things by 5p squared q to the 3rd. I'm just going to write them all down to start here. I don't care for p's and q's. They're kind of hard to write, and it's easy to get them confused. All right, and they kind of look like 9s. All right, so we know that 15 divided by 5 is 3. Now, one thing you could do, if you want, is just go through and do all the numbers first. 20 divided by 5 is 4. 5 divided by 5 is 1. Okay, and then we see here the p's are actually going to cancel each other out, and we end up with a q here. And then the we end up with a p here because p to the 3rd over p squared is just a p. And then the q to the 5th over q to the 3rd is a q squared. And then this one, almost everything cancels except we have 1 p left over. Okay, so if you can remember that quotient rule, you're going to be perfectly fine. All right. Whoops, nope, it's down here. Oh, here we go. This isn't what I was talking about before, but this is an example of one that really has thrown people off in the past. People look at this and say, oh gosh, do I need to distribute and then combine like terms and do all that stuff? Nope, don't distribute, don't combine like terms. This is actually super simple. So whenever you have something in parentheses and something on the outside, it's multiplication. So technically, the 5 is a factor of this first term, and the x plus 3 is a factor of the first term. Okay, so if you're thinking numbers, it's kind of like if we had the number 8, right? Whoops, I don't want to do that. And we list the factors, we just do 1 times 8, 2 times 4, right? Well, in this case, we don't have numbers. We have a binomial, and the 5 is just one of the numbers, like down here with the 8, and then the x plus 3 is just like one of the numbers too. It just happens to be a number, but we just don't know what part of it is. Okay, so let's get rid of that. But So again, the x plus 3 is a factor of the second term, and the y is a factor of the second term. Okay, so hopefully you can see that the things that I highlighted in blue are exactly the same. So if x plus 3 is a factor, and it's common between the two terms, and there's nothing else they have in common, that means the greatest common factor is x plus 3. And we're going to need to write it in parentheses. Okay, and then we just do the same thing that we did before, where we make parentheses, we put a plus sign in between, and this one is fairly easy to see what's left. It's what I highlighted in green, so it's 5 and y. Okay, so essentially what this is, it's just multiplying two binomials together. And we're given one of the binomials in the original problem, and we just have to recognize that what we highlighted in green is the second binomial. Okay, so you should be able to look at these fairly quickly and just be able to come up with the answer pretty quickly. All right, one more. And this one involves fractions. And fractions can be a little tricky because people look at it and they're like, gosh, I don't know, 3, 1, 5. Well, actually 3, 1, and 5 have nothing in common, but they all have 1/7 in common. Okay, so if we think about it, 3/7 is equal to 3 times 1/7. 1/7 is equal to 1 times 1/7. And 5/7 is equal to 5 times 1/7. So there we go. We just identified our greatest common factor between the numbers as 1/7. Okay, but you might be saying, well, but it's so small. It's smaller than 3. It's smaller than 1. It's smaller than 5. It doesn't matter. As long as they don't have anything else in common, our greatest common factor can be pretty small. In this case, it's 1/7, which is pretty small. So I can write this down as 1/7. And, whoops, hold on. I don't want to go that far yet. I need to identify the smallest exponent on the variable. That's x squared, right? So that means my greatest common factor is 1/7 x squared. And then I just create parentheses here. And so in this case, if we tried to do the method where we create fractions, man, we're going to have fractions and fractions. It's going to be really kind of messy. So the way to do this one is just look at what we did over here. You know, what we did over here gives us the numbers 3, 1, and 5. So I could go ahead and write 3, 1, and 5 in here because I already know that those are the numbers that I need to put inside the parentheses because I went through the process of finding the greatest common factor. And then as far as the variables, it should be fairly easy just to look. So we have x to the 4th and x squared. Well, that means we've got x squared. And then x to the 3rd and x squared. That means we've got x. And then in the last one, the x squareds just cancel, so we just have the 5. So our factored polynomial ends up looking like this. All right, so you have, I think that's it. Yeah, you have an assignment now to do. There aren't too many problems to do, but it should be enough to get you a good refresher on factoring by GCF.